Hello, good morning, good afternoon, good evening, everybody, and thank you for joining the webinar today. Today we are going to be talking about 5G networks with a very catchy headline, How to Secure the Future. Obviously, we are going to be talking about the security element of 5G. We have seen that 5G has been extensively deployed already throughout the world, and we are going to address some very important questions about how security is going to be treated in the 5G world. Obviously, we have seen in the past that there were security gaps in previous networks, and the overarching question here today is how will 5G or the transition between legacy networks or existing networks into 5G change the security threat, and what service providers and mobile operators should do about mitigating the threat as they transition. Obviously, there are lessons that have been learned in the past, and adaptive mobile security is certainly one of those experts that can tell us what we've learned from the past and how to deal into the future. Without going too much into the topic of the discussion myself, I want to leave it to two of our speakers who are experts in the field. The first speaker is Kahal McDade. Sorry for my pronunciation, Kahal. Kahal has a very, very strong background in security. He's a Chief Technology Officer of Adaptive Mobile Security. He is one of the world's leaders or recognized expert in network signaling security. His experience goes across very different applied areas, but I think some that is worth mentioning is his role in the GSMA as one of the primary contributors to mobile security work. So he's not only applying security, he's designing how to do security for the entire service provider mobile community. Amongst the areas that were authored by Kahal, I think is worth mentioning SS7 interconnection security monitoring and firewall guidelines, as well as 5G interconnect security guidelines. Obviously, his work is not only academic, he's consulting the US FCC, which is a very, very good credential. And for more details on his profile, please refer to the bio that is attached to the webinar invitation. Together with Kahal, we are going to have Dr. Silke Holtmans, Head of 5G Security Research at Adaptive Mobile Security. Dr. Silke has joined as a head of 5G security research, and her background previously is with Nokia Bell Labs, where she was a distinguished member of the research staff. Currently, her work is to combine research and data analytics, penetration testing, and privacy. Obviously, again, exploring and investigating vulnerabilities of networks and security attacks on SS7. Again, for more details about her background, I would refer back into looking at her profile and full bio on the webinar invitation. And without further ado, I would want to pass the presentation on to Kahal. Kahal, stage is yours. We're looking forward to hear more about how security threat is working and how you are helping service providers in mitigating such security threat.
Hi, everybody, and thanks very much for that introduction, Dario. So I'd like to welcome everybody again to this presentation. My name is Cathal MacDade. As Dario mentioned, I'm the CTO of Adaptive Mobile Security. I am joined on stage here today by my colleague Silke Holtmans. She is, as Dario said, our head of 5G security. And today we're going to be talking about a topic which is, I'm sure we hear about all the time in the community, which is the 5G network, and also another topic which we also hear all the time about, which concerns is 5G security. And what we're talking about is we are looking at this from a different angle. We're trying to explain what are the type of pitfalls that operators may encounter when it comes to the 5G world. And I hope that over the course of this presentation that you'll find this informative and useful for your organization. We're going to be releasing a white paper based on this research that we've done today, and I'll give you more details on this towards the end. So first of all, to give a brief introduction about who we are and what we do. As part of Adaptive Mobile Security, we are a company that's really dedicated and focused on mobile security for mobile operators. So essentially, we're not an infrastructure trying to add on security to other products. We are a company which has started from the very start trying to make sure that mobile operators are secure, especially from the core network perspective. We are currently deployed in over 80 operator networks throughout the world. We process literally billions of different events every single day, analyzing signaling events, messaging events, every type of event to see if we can uncover any type of attacks. And this gives us a real unique perspective on mobile traffic and what type of security threats are actually possible there. We built up a huge amount of intelligence, which has been recognized by industry through the years, but we've also built up huge amounts of experience in looking for different types of attacks. And this experience really helps us then in trying to project what type of attacks, what type of threats there may be in the actual future. So take it forward a little bit. If we talk about the world's networks and 5G networks in particular, this is a graph which is sometimes produced and used to illustrate the growth of the 5G network. Something though that this is important to realize is this is really talking about the radio connections, but certainly we can see from 2019 it's expected that 5G radio connections will start to increase and 4G will start to taper off, and you can see there a big decline in 2G and to a lesser extent 3G. So if you were to look at a graph like this, you would be thinking that, for example, that 5G is an inexorable increase and 2G and 3G is declining quite rapidly. But this, as I explained, is actually the current state of what's happening on the radio network side. And this is not so much of importance for us because, as we know and what we see in the world today, is that many operators are announcing 5G radio rollouts, but on the core network side, which is the area that we're concerned about, things are a little bit different. Currently in the world today, and I was doing this analysis earlier on this week, if we were to analyze what mobile operators have and don't have, you see the vast majority, which I took a sample of 600 mobile operators, the vast majority of them have both SS7 and diameter intercarrier connections. Now SS7, as we know, is the backbone for 2G and 3G, and diameter is the backbone for 4G. And over 90% of operators have got both connections. Very few operators, very few operators only have one or the other. And the reason why this is that even new operators with 4G cores and 4G radio networks, they still often need a lower level 3G interconnection because they need to send information, possibly text messages and so on. And just to show you the intricacies of how this looks, on the right there is a visualization of 3G connection of SS7 connections. The blue dots tend to be intercarriers and the yellow dots are actually mobile operators. So you can see that it's a really complex structure. There's many different routes in and out of mobile operators. On 4G, it looks roughly the same, and it shows that there's different connections for mobile operators using the different technologies. And as I explained, even operators which you might believe might be a 4G only situation, they often have 3G connections and they often have 3G elements. So this is the current state of the infrastructure. And if we look at security, as I'm sure you're aware, there's been a lot of reports of attacks on mobile core networks using intercarrier protocols over the last couple of years. Certainly what we've seen and what we've often reported in the media, in our research, in our different blogs, and what we've researched the community, is that over 2G and 3G, over the SS7 interface, which is the interface that mobile operators use to connect for these protocols, we see a constant volume of attacks. And most of those attacks are kind of say is more like suspicious activity, but a small percent of it is quite malicious. The vast majority of it is actually probably noise, what we classify here, but a small percent is malicious. And to show the percentage, the scale of it, here is a presentation which we had shared within the GSM community, but not so much internally, or not, sorry, not much so much externally. And we could see that roughly the vast majority of this, 68%, was of this threat level, what we between 2 and 3, but we perceived there was a certain amount of traffic, roughly around 3.2%, between 3 and 4% of traffic, which we had analyzed and classified as really malicious. So what these types of really malicious types of attacks are will be things like location tracking or call interception. So we can see a constant, small but constant set of attacks which we see over the SS7 interface. And often what we see over core network attacks, the types of attacks we see are often low volume but high impact. If we look then at the 4G network, it's a slightly different story. We don't see the same amount of volume of attacks at the same level as the SS7 interface. However, it's gradually rising. And here is just an example of a type of attack that we'd seen 1 or 2 years ago. Just an example that we saw a mobile network was being tested. And essentially what they were trying to do here was that the attacker was trying to see at what point did the operator's defenses kick in. So they were trying to move or pretend that a subscriber was moving around the world at increasingly fast speeds to try to detect at what point they would actually block it or not. So we're seeing experimentation and attacks from attackers that they're probably still focused on the SS7 side, but they wanted to see what was possible on the diameter 4G side. And this is the type of analogy a little bit that we expect to happen in 5G. Most mobile operators will still be connected over 3G and 4G, and when 5G comes in, the attackers will still focus on getting what they want, but they're also going to try to experiment to see what is also possible using the new technology. And of course, we do see attacks over other mobile network interconnection protocols, GDP and SIP. And here are some blogs and some information where you can see some of those attacks. Now, as I mentioned, we see a very small percentage of the attacks that we classify them as quite sophisticated and malicious. And this is because, unlike possibly other network protocols, it's quite difficult to get access to mobile core networks. But when you do get access, the type of people who are using it are normally real sophisticated types of attackers who are professionals, who are well paid, and got a large infrastructure behind them. And one illustration of this, an example of proof of showing how this works, is a type of attack that we profiled last year, which we called the SIMJacker vulnerability. And what actually happened here was that in Latin America, several countries in Latin America, we came across a particular attack which has been executed by a surveillance company where an attacker was tracking tens of thousands of mobile phone users by text message. How the attack would actually happen is that either the attack would come in from a handset or for connection from a computer, what we call attacker VASP, or from over the SS7 interface. And the reason that the attackers did this was that these particular operators had SS7 and diameter defenses in place. But from the attacker's perspective, they don't necessarily care about technology. What they care about is they want to get the information about their targets. So they looked at what was available, and then they figured out a way that they could try to avoid these defenses which are currently in place. And so the takeaway we took from this is that attackers aren't so much constrained by technology. What they will do is they will use any type of technology in order to target what their real objectives, which is not the technology, but the actual target subscribers. So they're going to try to use any potential vulnerable route if one exists. We can't make the mistake of thinking that we can only silo and protect one technology or another, because the attackers don't think that way. How they think is that they need to get information, they need to intercept the phone call, they need to get the location of a target, and they're going to use whatever method that they can use to actually achieve that and get that. If you're interested, we've quite a detailed paper on this particular attack and how it developed and the different profiles behind it. And you can go to our website and our links and download that report. It's quite detailed and well worth a read if you're interested in this area. So moving on to the area we're talking today, 5G, you might be asking yourself, well, is 5G going to solve everything, and is 5G going to save us all and 5G to the rescue? Well, certainly 5G was designed with several security improvements in mind, and I've shown several of the main highlights here. I bolded the first two here at the top, which is basically interoperator network security and increased home control. And what these two topics are is that, finally, you could say, is that within, at least in the 5G network, security is now built in by design. Whereas with 3G and 4G, we were having to add security afterwards. In this particular case, 5G is theoretically built with security in mind from the very start. Another quite good improvement in the 5G intercarrier network is now that we've got what's called increased home control. And what this essentially is that there's proof that a mobile device is actually roaming in another network. In the past, and certainly in 3G and 4G, it is possible to not easily, but be able to spoof that a subscriber is roaming in a different network, which is what I showed briefly in the diameter example. And in the 5G side, hopefully this should be much easier due to the designs. So then, based on this, we have to ask ourselves, does this mean that 5G is secure and has no security problems? This is a big question we hope to take you through in this presentation. And on that point, I'm actually going to now hand over to my colleague Silke, who's going to take into more detail about the research that we've done in this area.
Thanks, Cathal, for the nice introduction. My name is Silke Holtmans, and I'm head of 5G security research at Adaptive Mobile Security, and I'm now going into the research that we are doing in that area. So in the moment, you see here some deployment status of GSMA and of the 5G networks. This is mostly radio access networks. So it doesn't say much about the 5G core network deployments, but we already heard that, for example, T-Mobile US, Telstra, and KDDI announced 5G core networks deployments and so-called 5G standalone architecture, which means pure 5G networks. So 5G networks are coming, and here we have different deployment variants of 5G networks. Let me take you through it. So on the left-hand side, you see the blue 4G, and basically you have this green new radio plugged in as a slave to a 4G base station, which basically means you have some new base stations in the fields, 5G base stations, but you don't have the bandwidth, and also you don't have the speed that you have with a full 5G network. Then in the middle, we have a 5G core network, and we plug a 4G base station as a slave to a 5G base station. This already improves performance and everything, but the best option is, of course, the right-hand side, where you have a 5G core and a 5G new radio. Now the question is, this is a migration scenario, basically. So how do you get from 4G to a 5G core? And you could say, okay, it's done by magic. It happens overnight. So that would be sort of migration-assisted 5G instant core. But of course, we know there is no magic, and this will probably take several years. As you already saw in the beginning with the statistics, we will have all kinds of deployment scenarios for a very long while. So what we have a 3G and 4G core, which is basically a lot of little details and elements. And this is diameter protocol based. It's SS7 map based. Then we add to it a 5G core, which has a completely different architecture. So it's really much more IT than the previous generations. So there we see protocols like HTTP2, REST API, JSON, and actually everybody of you, I'm pretty sure, has used REST API. Everybody who has been going shopping at Amazon has used the REST API even without knowing. So these are basically IT protocols, and these need to be combined, this point-to-point architecture and this service-based architecture in the 5G core, where every node can talk to any other node and send messages there. These have to be combined into an operational network which supports legacy. As we saw with the graphics before, that the partners have to support legacy for service roaming, for traveling and other use cases. And let me now talk a bit about attackers. Here we have an attacker, not the usual black hooded person with some 29 and some typical names. But let's call her Gloria, and she's 65 and she loves pink, and I want you to think a bit differently about attackers. And what I want is that attackers are usually part of a service company, surveillance service. They are hired to perform a task. This task can be eavesdropping, it can be location tracking, it can be fraud, it can be denial of service. So they are supposed to deliver. And if you look at, let's say, WikiLeaks or similar places where you can sometimes find some email archives of these kind of companies, you will see that they use a toolbox basically. They have attacks for 2G, for 3G, 4G, and I suppose they will also work right now on 5G attacks and potentially also on vertical attacks. And for example, with the SIMjacker, you could easily see how flexible those attackers are. And they use SS7 and they use mobile originated attacks. It's the same go for them. If one doesn't work, they just use the other. So 3GPP has done an excellent job on their air security. There were a lot of good improvements in 4G and 5G. And if we think now from this kind of surveillance service company, it's very messy to send people into the fields with false base stations or similar equipment. These field workers would need to travel, so it's much easier if they try to come in via the back end, so via the interface between the operators. And let's have a look at the IPX. This is a very, very rough picture of the IPX. There are about 2,000 partners in the IPX, so this is really, really very high level. And we have their value-added service providers, which provide, let's say, SMS service for dentist reminders or similar. We have IPX providers, which provide routing services, roaming hubs, which enable broad roaming to a lot of partners. And all those partners, they have different technologies. We see in the same networks, we see 4G connecting to 2G or 3G to 5G, standalone or non-standalone. So all kinds of combinations are possible. So there are a lot of migration scenarios here possible. So let me now introduce you to the first migration scenario. That's a mobility migration. We assume that an operator has bought a lot of 5G base stations for the city centers, and then for the countryside, there would be still 4G base stations, which is a reasonable assumption. And in addition, there's a roaming scenario. So you are roaming to this country, which is half covered by 4G and half covered by 5G. And your home operator would be a 5G operator. So this kind of scenario looks then roughly like this. Don't be afraid of all these boxes. I try to classify and group them a bit so it's a bit easier. So on the top, that's your home network, this big green box. So that's your home network. This home network has 5G, and all green boxes and green arrows are 5G. And the network which you are visiting, the yellow network on the bottom, it has, on the left-hand side, it has 4G, and on the right-hand side, it has 5G. So, and you move around in this country. You're visiting nice sites and so on. So your home operator, actually, even if it's a 5G operator, it's supporting legacy, which means why you have this little greenish white boxes, which are sort of combined boxes. You have their 5G and 4G combined because you want your home operator wants to support roaming so that you can enjoy all the services. So what I'm now interested in is this transition between the big green box and the yellow box on the bottom, because that's where the messages go through the IPX. So all the errors which cross this line between yellow and green are going through the IPX, somewhere all over the world. And the question is, as we explained, how can we protect this against these kind of surveillance service companies? So on the right-hand side, with this N8, N24, N16, these are the so-called service-based architecture interfaces, and they use HTTP2 and REST API. These are internet protocols. And those are 5G protocols, and the attacker might use that vector to get in. And these can be protected by a new node introduced by 3GPP called SEP. That's a Security Edge Protection Proxy. So you have covered that area. But you still see there are errors which cross the line, and they are not protected. So the next thing is your user plane traffic, which really means your user data. How to protect that one? It goes also between one network, because we have here a home routed scenario, which is the most common scenario. This would be the N9 and the S8 user plane. The attacker might try to intercept your data or sort of doing some malicious things with your data. So an attack there would be protected by user plane protection. The older network generations, they have control plane using GTPC. That's S8C. That's not common in 5G, but it still exists in 5G, but it's not used for that purpose. So an attacker might try to redirect your traffic or something like that. And you want to also protect against that. So you need a fine-tuned GTPC firewall. And for the pure 4G traffic, there might be diameter attacks. And for these ones, you need a fine-tuned diameter firewall. As we said, the attackers might have a toolbox and try out one or the other and trying to see how they can get in. But there's a possibility to correlate attacks. And by this correlation and information sharing between those different types of firewall, getting really a strong foundation to stop attackers getting into the network. This is basically what we just discussed was the migration from 4G to 5G for the roaming scenario. And another migration scenario that I would like to discuss is the subscriber database migration. The subscriber database is a very, very sensitive node in an operator network, because if the subscriber database has a technical problem, then it could be that the whole country suddenly loses connectivity. And that's a very serious thing. So we will have a look how the user database or subscriber database could be moved forward from 4G to 5G in a secure manner. So on the left-hand side, you see in green the 5G, the different databases for user data and subscriber data. And you see on the bottom the 5G core, which is connected to the IPX. On the right-hand side, you see the 4G databases. And on the bottom, the 4G core, the EPC, and IMS, which takes care of things like voice. Now, as we discussed briefly before, 5G used the service-based architecture. That means all the nodes sit on a bus, and each node can talk to each other node, while 4G has a point-to-point architecture. So to bridge this architectural problem, 3GPP introduced something called a REST API for the HSS, that's a home subscriber database, which means that the 4G node is actually sitting on the 5G bus. So all the subscriber data sits then on the 5G bus and is addressable from this bus. So now let's go back to the 5G core in the corner. This is connected to the IPX. So you might have an attack coming from the IPX, and it might not directly target directly the 5G database, but it tries to carry some information and some attack to the HSS. So there's a potential that a 5G protocol could carry a 4G attack through this HSS API. But a well-configured SEP can also take care of these kind of advanced scenarios. But we have to think about these kind of scenarios. Another scenario which we have to think of is that we have a fully protected 5G core, and then we do some proprietary integration, which is also sometimes very common in operational networks. So here we have the proprietary integration of an IMS together with a 5G service-based architecture. And now you might think, okay, we have here the security edge protection proxy on the left-hand side, which secures nicely the 5G system. But on the right-hand side, where we have the interconnect border control function on the right-hand side, and this topology hiding function, topology hiding gateway here, an attacker might come in through that one and basically attack your UDM or HSS via the backdoor. Now you might say, well, that looks like a bit of an advanced attack, and is this really sort of feasible, or do we really need to worry about it? It looks a bit far-fetched. But if you look at the IT world and remember that 5G and in general telecommunication is moving forward towards IT protocols, this is not so far-fetched. There are tools like Bloodhound out there which can map, let's say, an enterprise network, and you get in from one point and it maps you the attack path to your target. And of course, Bloodhound is not designed yet for telco protocols or for telco information elements, but it's not so far-fetched to assume that this kind of topology mapping for telco networks is impossible. So we need to think about these kind of new threats and new attack vectors. So let me give you a brief summary of the toolbox. So for SS7 attacks, you use an SS7 firewall, which is already partially deployed and we see today. Diameter attacks, that's 4G, you need a diameter signaling firewall. For 5G, it's a standardized SEP plus threat intelligence to discover new attack vectors and especially also changing attack vectors, because when the attackers notice that their messages get dropped, they still want the data, so they just try a bit of variation on their attacks. Then there is bad configuration and also operation. So pen testing and scanning helps there. For GTP attacks, it's the GTP-C firewall that helps you there. For bad user traffic, that's the GTP2 traffic scanner. And for bad security quality, GSMA and 3GPP has the security assurance scheme, which helps with that one. So you might say these are quite a lot of measures, but if you think of it in terms of enterprise networks, we all have our BitLocker, we all have screensavers jumping on, we have VPNs and so on. So telco networks are not that different. So each of these different protocols needs different protection. And for migration, it's important to consider what interfaces are open, what protocols are they supporting, which partners are using them, are the partners also migrating, how fast are they migrating. Security is an evolution, and it's important to understand that threat intelligence and evolution is absolutely necessary to counter those attacks. So, and for a look beyond migration, I want to give it back to my colleague Cathal. Thanks.
Okay, thanks, Silke, and thanks for that. So taking on a little bit further, if we were to look at, and as we have looked at in this presentation about the migration, let's also have a quick thought about how things could look potentially past the migration. Like many of the great migrations of the past, there's certainly going to be strength in numbers as mobile operators try to move from 4G to 5G. And as we've explained, there's a lot of threats, hidden and otherwise, which may actually affect mobile operators. And there are things that they need to do to make sure that they're protected against those threats when they arise as mobile operators migrate from 4 to 5G. We have to ask ourselves a question as well, like if we move straight over to 5G, is that stage we consider ourselves completely secure? And there has been some statements in the press on different bases that 5G will be the first mobile security system to be truly secure, or comments that end-to-end in 5G security means that there'll be no more attacks. And this idea is that if we move over to, as Silke explained, a standalone radio and a standalone mobile network, then mobile networks will be completely secure because they won't have the incumbents of a 4G and a 3G connection. But we don't expect that to be the case, and it can't be the case due to several different reasons, at least because, as we covered in previous 5G white papers, 5G itself is a combination of many new and complex protocols, and anywhere you have complexity, unfortunately, invariably, you also invite the possibility of introducing new vulnerabilities. And 5G itself is reusing a lot of protocols which have been used in the IP world for many years, and these protocols have been subject to attacks for many years. Also, 5G also introduced the idea that we could have new potential types of threats. In the past, the mobile networks, that they quite well understand what's operating within their network, but the idea of different processing units, especially slices, means that there could arise a situation where mobile operators will need to monitor as well closely the information that goes out of their network as well as going in, because they could have the idea of rogue slices and malfunctioning slices and so on. And last but not least, as we covered earlier, what we see in the world today over 3G and over 4G is that we do see motivated and well-paid attackers trying to use these networks to try to target people, individuals, and even countries. This is not a theoretical exercise. This is something we've seen in real life. We've proven such attacks as a SIMJacker attack. And these individuals are being well paid by their customers to make sure that they obtain this information. And they will have, as part of their objectives, that they need to be able to still get this information on their targets regardless of the network technology used. So it can be guaranteed that if there is any potential vulnerability whatsoever, that they will try to exploit it and find it and use it against individuals, regardless of the network technology, even if it is 5G only. So the way we as a community can always try to deal with that is what we always say is that we need to correlate the information that we have. Don't just be stuck in one silo. Use as much intelligence as we have, like threat intelligence analysis. Don't believe that everything is working as it should, and just because you don't see any attacks, everything is fine. And most importantly, security mindset. Unfortunately, with security, you can never truly win. It's something that you have to be vigilant on. You must keep investigating. You must keep determining, are you secure or not, and must keep looking to see what is happening in your network. Because without that, sooner or later, these attackers who are well paid and motivated will find an entryway, they will find a hole, and they will manage to penetrate your attack and attack your subscribers. As I mentioned at the start of the presentation, we are issuing a white paper based on this material. It contains material we have in these slides and much, much more. So I highly encourage you to go to our website, www.adaptivemobile.com, and download this website for free. And I think you'll find a lot more information in here if you're interested in the topics that we covered today, and more information can help you in your organization and your operator to try to make these decisions for the future. And with that, we have some time for questions, and I'm going to hand over to you, Dario.
Thank you, Kahal. Hello, can you hear me?
Hi there. Hi, Dario.
Hi. Thank you, Kahal. I can see we have already a few questions coming in, but just as a reminder for everybody on the call, this is now your chance to ask questions to the presenters. Let me kick off with one of mine while I give some time to people on the call to type in. As Kahal, as you were presenting, I could not resist thinking about something, which is a very high level, but it's very much a curiosity at the moment. As service providers, they're all working on deploying 5G, NSA now, and very soon SA. So is your expectation that in future with 5G deployment, we will see the number of attacks actually increasing, or the nature of the attacks actually increasing and changing?
Okay, yeah. So that's a good question, and I guess the best way to make an answer, make a judgment to that, is based on what we've seen previously. So when it comes to the SS7 and diameter interface, we don't volume-wise see a huge amount of attacks, but the attacks that we do see are quite impactful and they're quite targeted. And I think that's a function of two things. One is that the sophistication of the attacker, it's quite difficult to craft these attacks. And then probably more importantly, the access. With SS7, it's quite difficult to get access to this network. And we see something like the same that is happening in diameter, and we see actually less attacks in diameter than we do over SS7, primarily because most of the attackers are focusing on that. So that's the 3G and 4G world, but 5G is a bit different. With 5G, it's possible that access could be increased to the 5G network because we have the idea of slices. We're going to have many more users of the 5G core network. So in a roundabout way of answering your question, I think when we start to deploy 5G networks, we'll probably have a fairly low incidence of attacks. But once we have the more 5G core networks out there and more users of it, I think we may well see an increase in attacks. Certainly up to the level that we see in the SS7 world, and possibly beyond that, but there's a lot of time between then and now.
Thank you. And I can see now quite a lot of questions are coming in, so I might start with the one from the audience of the webinar, and thank you for submitting it. So the first one is if you can speak about high-risk vendor attack and vulnerability vectors against 5G core in both NSA and SA 5G core scenarios.
Okay. The word vendor is an interesting one. I guess the different types, well, to take the vectors first, eavesdropping, denial of service, as we show in our paper and as Silke has discussed a little bit, we expect to see that the types of attackers who are executing these attacks on core networks at the moment, they have certain objectives to fulfill. They need to primarily track the location of people, gain information on their whereabouts, and also gain information on phone. But occasionally, and it does happen, they also do things like try to do data interception and voice interception. So we also expect that all of these same types of attacks and types of vectors will be tried to use in 5G, as we showed in our paper, which, as you've said, is available for download. In theory, it is possible also to do the same type of location tracking, the same messages, the same functionality is there. On the high-risk vendor attack, I mean, vendor security is something different. And when it comes to 5G, there's certainly been a lot of discussions on particular types of vendor securities, and supply chain security. But in general, when it comes to the 5G network, what we're looking at here is how the standards and how the functions interoperate with each other. I don't think it really makes too much difference which particular vendor is going to be developing it. What we're presenting here today is based on our understanding of how the standards are developed and how mobile operators are likely to migrate to the 5G network.
Okay, thank you for that. And the next one, I'm not sure is for Cathal or Silke. I think Silke also mentioned something around this topic, which is about if 5G. The question is around can attacks if 5G non-standalone and standalone core network is well secured, can you still have a scenario where the attack can come via a 4G core that is not secured enough?
I mean, in a complete 5G standalone network will have some interworking functions for many, many years to come to for legacy partners. Also, if you have still 4G base stations in the field, and you might have a MME, that's the management box, 4G management, mobility management box for those base stations. If you have still those, you also need to support 4G interfaces, which is of course then a 4G attack surface. So potentially yes, if you don't take care. So there will be still a 4G attack vector even in the 5G standalone network due to interoperability and legacy support.
Okay, thank you.
But it can be, it's not that we are helpless. Things can be done, but they need to be done. So.
Okay, and I think the other question is more of someone seeking an advice from your expertise. So there is a preamble to that question. So we know that 5G will offer the opportunity for more connected enterprise services, national critical infrastructure, IoT, and smart cities. And I think the question is, what is your advice for service providers and governments looking to create a secure environment for client data and services in 5G networks?
Services like smart cities or large IoT providers or critical infrastructure, they are very important, and for them things like security, availability and privacy of data is key. Therefore that should also be part of a service level agreement, not only things like which are classical, let's say bandwidth and availability. So that basically security becomes a value also for an operator to invest in, so that both sides benefit from this. So if an operator invests in security, then he can also attract high-value customers, and also vice versa. You know, as a customer, as a service customer, that the operator has taken care properly of the things and of your data. So make it a qualifier.
Okay, so security becomes almost a service rather than a protection to the network. The next one is a bit of a long one. I'll try and summarize. So is there any possibility of like a huge amount of 4G and 5G devices to expose modem APIs in a way that it could cause a potential denial of service attack towards AMF or even MME platforms? Then there is a second part, which I let you take care of this first bit, and then I go on into the second part of it.
There have been in the past, actually, there have been some IoT, I wouldn't call it attacks, I would say more glitches, where a lot of IoT devices, for example, where there was one encounter case where a backend server for an IoT company went down, and then the device couldn't reach the backend server, and they assumed that the network was down. So they were trying to reconnect all the time, and by that causing quite some load in the affected telco network that was a while ago. So these kind of scenarios can happen, but they can be mitigated. The GSMA has actually some IoT device security guidelines, for example, to have some sort of random timer so that not all devices connect to the network then at the same time or things like that. So, but the question is, of course, if they do it intentionally, which gives the whole thing a different flavor. So, but I think there, these kind of new virtualization possibilities, denial of service mitigation approaches, gives us some opportunity sort of to deflect those attacks. So the new virtualization technology might also help there in then ramping up more resources to counter these kind of things.
And then there was a second part to that question. Yes, please, Cathal, go ahead.
Dario, just that's a good answer from Silke. And just to add an additional point, I mean, perhaps one thing we worry about these sort of malicious attacks of huge amounts of devices. I think there's also a very strong possibility we have to be worried about even accidental attacks, because we are going to see
a huge amount of devices in the 5G network. At the moment, many operators, their traffic profiles and certainly their voice and messaging profiles are all based on human users. But with the large-scale connected cities, we're going to see traffic patterns where probably the majority of users are going to be non-human. As a result, then we're going to see, and these non-humans don't behave, and we're going to, in ways that we expect humans to. Basically, we're going to see spikes at certain times. So there could be spikes at different times, which form a sort of accidental service type attacks. And this is something which we've encountered through the generations. As Silke has mentioned before, something like this came up when the first mobile apps, and we had to get more efficient app libraries and usage. This is something we just need to keep in mind when we consider one of the changes that 5G will bring.
Thank you for the follow-up, Cathal. And so I want to get into the second part of that question. I hope I can paraphrase again. So this one comes again from the assumption that there will be more IoT devices and also more tools available for developers. And the question is there any reason to have I guess it's NSA firewalls instead of only thinking about potential attacks from IPX integrations such as SS7, diameter, GTP-based attack in legacy networks?
Okay, I'll go with that.
Okay,
I don't think we're saying you must be one or the other. Definitely, in the world today that we see, the vast majority of attacks we might be aware of, at least from our perspective, are coming up in inter-carrier core connections. I guess the difference with if you see radio type attacks, is difference in those is that they tend to be locally focused or locally based, and the dangers with inter-carrier attacks from IPX integrations, as the question mentions, is that those can potentially affect the entire network and not just maybe one radio cell or one core segment. So that's when operators, when anybody starts to categorize vulnerability and risk, they look at the overall risk from the network, and you can see that there is, even though maybe low volumes, the risk is quite high from attacks over the intercarrier aspects of it. But then, of course, it could potentially be quite damaging to have, if we have overload conditions in local areas and cells or ENOBs or what have you in the 5G side. So certainly in those situations, I would be thinking that operators would need to look at what sort of controls and mitigations could put in those places. But I don't think it's one versus the other. All of them will be need to take into account, but you have to also take into account the different targets and the different impacts that those different types of attacks could have.
Thank you, Cathal. And I think the next one is again back to Silke, and I think it's touching on something you described during your presentation. It's and it reads more of as a statement, but I guess it's asking for you to comment on it. It's because 5G is relying on IT protocol, so the nature and the diversity of attacks will increase, and vulnerability on HTTP has to be taken care of as well. I guess the person is looking for a comment from your side. Yeah.
I think the nature of attack is already slowly changing in IPX. Sort of in the past, it was just that in SS7 you were sending a message and you were getting back the information. And now it starts really to look into details, how things are coded, which numbering scheme is used, and so on. So things are already getting more into the implementation specific of each node, sort of which node processes what. And now when we come to REST API and HTTP2, this will even more increase. So when you look at the CVEs for REST API, they are basically all implementation specific. So the diversity of attacks will increase because we will see all these little variants of, okay, this vendor implements it that way, the other vendor implements it that way. So, and in this combination, then there is potentially vulnerability. So we really have to observe what happens in the internet space on regard to parsers, to HTTP protocol, to potentially also to open source vulnerabilities and so on. So this will become more and more as we take more and more of those IT protocols on board. So I fully agree there. So that we have to keep a very keen eye on that and also update our firewall rules then with the latest threat intelligence so that it really sort of bites immediately and not just half a year later.
Okay. And the next question is specifically about SEP, whether SEP is used only to secure inter-operator communication or also used to secure network functions located on the SDA.
Yeah, so that's actually a very good question, and this is actually something that's been discussed within some of the various security working groups at the moment. Certainly the SEP with the Secure Edge Protection Proxy is the formal node to secure an inter-operator communication, but within the various working groups, and especially a group that I'm leading, which is the 5G Interconnect Security Group within the GSMA, we very quickly came across the fact is that we do have the network exposure function, the NEF, and that there are other interfaces which we didn't really have in the SS7 and diameter, other interfaces essentially to the outside world. So what it is looking like so far is that in our discussions and in this document that we're creating around this is that those types of interfaces will have to be secured by the operator. Now, they may not necessarily be secured by a node that's called the SEP, but they would definitely have to be secured and protected, and egress and ingress traffic be filtered as it goes, as essentially as all messages go in and out of that interface. So that's a very good question, and that's something we realized quite early on in those analysis that we were doing, that it shouldn't matter where the messages or where the communications come from. Anything that could potentially affect that poses a risk to the network operator, we need to be analyzing and filtering.
Thank you, Kaha. And the other, and I think we are approaching the top of the hour, so I'm going to ask maybe just another couple of questions, and I know there are many more, and I'm sure you can follow up directly with those asking the question. But the other question is very related to the deployment scenarios that we see today in 5G. Obviously, 5G is being deployed in metropolitan areas at the start, and obviously the subscriber will eventually go outside the 5G zone or coverage of the network and downgrade to 2, 3, or 4G. So the question is, will attackers wait until it downgrades, or when you are outside the 5G area, or what kind of attack scenario you envisage to see?
When you have a network which has combined 4G and 5G, then you have, as you saw in the notes, these kind of slightly greenish nodes which combine 4G and 5G functionality. And actually you have also in 5G the information elements containing your 4G location, for example. So it doesn't really matter if you are just happen to be in the 4G coverage or on the 5G coverage. The information is there in the core of the network, and that's where the attack would go. So yeah, so they don't need to wait till you move from one network type, radio access network type, to another network radio access network type, because in the core you have the combined information, and that's what an attacker would go after.
Okay, and I think we have just a very final minute before thanking everybody, so I'll just pick another one, and I hope it does have a kind of express type of answer to it. And it's about the way network functions are containerized at the moment, and how security is managed in a containerized environment.
Yeah, I can take that. So, okay, you can go ahead.
So I suppose that's now related to hypervisor security and or also potentially slicing. So hypervisor, I'm not sure which of these areas the question targets. So if it's about hypervisor security, of course you need to have proper IT security mechanisms for these kind of things, best with a trusted root of hardware to avoid basically some specific hypervisor attacks. If it's about slicing the question, you need to have proper slice separation and also authorization and authentication on slice level, so which would need to be supported by the 5G NOS function. So I'm not 100% sure which area the question targets, so you get two answers.
Okay, well, maybe this is a good chance to follow up directly with the person asking for it, because I'm afraid, Kahal and Silke, we have run out of time. It's been a full hour, and thank you for taking all the questions from the attendees. And with that, thank you to Adaptive Mobile Security for sharing their views and their knowledge with us.
Thank you, Dario.
Thanks a lot.